Alright, let's evaluate the following limit. Limit as h approaches 0, 2 plus h squared minus 4 over h. You can notice here that the restriction is very apparent. If you see that the limit h approaches 0, when the denominator is equal to 0, this whole rational expression is going to be undefined, right? So we need to get rid of this h on the denominator. So let's look at expanding out the numerator. So we have this 2 plus h squared, and I'm going to expand this out like I would expand a plus b squared, which is a squared plus 2ab plus b squared. I would just memorize this template. It makes it a lot easier to do expansions. So here we get 2 squared plus 2 times 2 times h plus h squared, which is 4 plus 4h plus h squared. Okay, so that's the expansion for the numerator, and then we get limit as h approaches 0, 4 plus 4h plus h squared minus 4 over h. Okay, now at this point I want to just do a little bit of collecting like terms. We have a 4 and a negative 4, so if you collect those guys together, it cancels out, right? So now we're left with 4h plus h squared. You can notice here that this 4h plus h squared, there is a common factor where you can actually factor out an h, so you get 4 plus h, right? So the greatest common factor between these two is this h. And instead of writing 4h plus h squared now, I'm going to write this as h times 4 plus h over h, limit as h approaches 0. Okay, and you can notice here that now the h's can cancel out, which gets rid of our problem of an h being on the denominator, and now you can actually allow the limit h to approach 0. Okay, so when h approaches 0, then we get 4 plus 0, and then we get 4. So excuse me, so the limit will be equal to 4.